So let's talk a bit about like your research and your work here, because actually, to be honest, it's a completely alien thing to me. I mean, obviously, I did a little bit of research, only very
All right,
briefly,
okay.
before you came here, trying to figure some of it out. It's to do with materials. Is that right?
Yes, yes.
I'll let you elaborate.
Right. Where should I start? I don't even know. So I think that my most current project is that you're talking about probably is the Adisonic. This is a lab that was funded by Bournemouth University through Research England. So that's something that started. We started building it this summer. So everything is still ongoing. And it's a very exciting area in the sense that we try to predict the life of materials, especially novel materials like those obtained from metal additive manufacturing, for example, where you don't have predictability of properties as you had for other materials. And we do that in a very fast way, an accelerated way using ultrasounds. The technology already exists. I was involved in a project before when I was in the University of Lisbon in Portugal. And basically what we're doing is replicating and embedding new stuff in the lab we've got here to test those materials. So so that's what it is. It's a fatigue testing, basically.
I see. So novel materials, as in materials that haven't been used in producing things previously. Is that what you mean by novel materials?
Yeah. So the thing is that now when we obtain things from additive manufacturing, they are printed, for example. So and you could print them, for example, with horizontal layers or vertical layers.
Okay.
And that will mean that you have what we call anisotropy, which means that the properties might be different in different directions. So whereas in regular metals, they are the same in all directions. So if you apply a load in the horizontal or vertical direction, the expectation is that they will behave the same way. When you 3D print them, that's no longer true. You can't just assume that. Then there are other issues like voids, defects that could be in the material. But that's one of the things. So in the past, you would be able to test alloys that are very well known, for example, EN8 or EN19. These are still grades. And you go to a data sheet and you know exactly what the properties are. There probably have been people testing them before for fatigue. So you know if you apply a certain cyclic load, how long it will last. There are then models to do that as well. So you could predict how long your part will last. This could be used, for example, when you do programmed obsolescence.
So what's that mean?
So so when you buy a light bulb in the supermarkets, although I don't work in this area specifically, but it's just to use as an example, it will say there that lasts, I don't know, for 10,000 hours. That's programmed obsolescence. They could have designed it to last for 20,000.
What's the second word you're saying? Sorry, program.
Obsolescence.
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 Sorry.
Sorry.
Sorry, no, my mistake.
No, it's my mistake. It's my accent is sometimes it's even difficult for me, as you can see.
As in, like, because Apple get criticized a lot for creating phones that have this built-in obsolescence, so that they intentionally, the battery wears out intentionally after a certain amount of time, because you then have to go and buy another iPhone or whatever it is.
But that's actually, for me, when I talk to my students, so I'm a mechanical engineer, that's my background. And when I talk to my students, I tell them, for me, that's the perception of quality I've got. For me, quality doesn't mean that a product is premium. What it means is that it does what it says in the tin, which is it's been designed to perform in a certain way, in certain conditions, and to last for a certain period of time. So I give you an example. I had a car some years ago, and after 3 years, the first headlight bulb went off, and I had to put a new one. And it was, I don't know if can I say brands? Maybe it was a Bosch, which is a German brand, very famous. And I had it replaced. 2 weeks later, the other one went off again. The opposite side.
Okay.
So for me, that's the meaning of quality. So this is amazing.
So you were actually impressed by that?
I was impressed by that because they basically lasted for the same duration, give or take 2 weeks. It's 3 years, and I think that was quite impressive. This is a good example for me to bring to the classroom. So that's,
I like that you've got that perspective. Other people will be going, "Oh, for crying out loud, both headlights in the space of 2 weeks," but you're there, impressed by the manufacturing standards.
Because when you design a product, you should also have in mind the obsolescence, the duration, the lifetime you want it to survive, because you might go out of business if it lasts forever as well. If you're selling washing machines and then they last for 100 years.
Well, I suppose that's why corporations get criticized for it, in a sense, isn't it? Because obviously it's ensuring their own well-being over what some people might say the environment or whatever, or this sort of stuff. I suppose that's a debate in itself.
It is, and I think the good news are, I think people and corporations and the new generations are becoming more and more aware of sustainability issues, of the problems with waste, and the Adisonic is in that we want to contribute to low carbon emissions. So the other side of testing very quickly the materials, the other aspect of it, so the aspect of being able to test, so you want to, I don't know, to produce something, you want to predict how long it will last with a new material that wasn't tested before. So you want it quick, so that you get the information quick, so that you are more competitive, obviously, and it is a lot cheaper because of that. But the other side of it, which is a positive as well, is that we can test, because it's so fast, to extended lifetimes. So the idea is that we start testing, and industries are starting to be interested about that, on what we call the very high cycle fatigue regime.
Is there an acronym for that?
Yes, that's so. If you the difference in testing is that the machine we use operates at 20 kilohertz. Right. This is becoming standard. There is no standard yet. There is a Japanese standard, but hasn't been translated to English yet. But typically, they are 20 kilohertz. There are two reasons for that. Reason number one is that you can't hear. Most people can't hear it. If it would be operating at 18 kilohertz, you would probably hear it, and it's a very uncomfortable sound. Above that, there are constraints in terms of the specimens, because we built coupons to be tested. I can explain that a bit later, how we do that. And they depend on that frequency. So 20 kilohertz means that 20 cycles per second. So in 1 second, we are deforming a part 20,000 times in 1 second. To reach 10 billion cycles, we would need, in theory, 14 hours. So I've done the math already.
Wow.
In reality, you need maybe 3 days because of some issues that exist with heating.
Yep.
But if you'd be using a classical rotating test machine at 30 hertz, which is 30 cycles per second, which is already slightly quick, it would take you for the same test, working 24/7, 1 year. You just do the math.
Wow.
And that's the difference. So talking about a couple of days to 1 year when you want to test on these extended regimes. So there is some interest in that, because not only because of extending the lifetime, but this brings other opportunities in terms of markets. You could, for example, I'm working on the business of maintenance or extending the lifetime of something. So in maintenance, how it works is you are always trying to bring the reliability up. So what you try to do is to, so something is wearing down, but then you could make something happen so that you bring back the reliability. So for example, an example is changing the oil in your engine, your car's engine. You do it every, 10,000 miles, for example. And the reason why is because what you want is to make sure that the lubricant you're using still has the viscous conditions it should have, that any debris that is inside, because there is wear, is washed away. You could still keep there the old oil forever, but the likelihood is that will wear down your engine more quickly. So what I'm trying to say is that there are techniques, and I was involved in a project where we did that. The objective is to treat materials. So this was a PhD student I had in another university, actually, but he was developing techniques to treat metals based in electromagnetic field treatments. And he observed a few things. One of them is that we can extend the lifetime of material with those treatments. The problem is, by how much? If you go to conventional testing, there is just no time to test and quantify that, so you need to go to these accelerated tests.